Question 10. A circle C has equation x squared plus y squared plus 6kx minus 2ky plus 7 is equal to 0, where k is a constant. Part A, find in terms of k the coordinate of the center C and the radius of C. So we know that the circle equation should always be in this form. And using this, we can easily find the center and radius. So for part A, we are first going to put the equation in that form by first writing all the x terms next to each other. So we've got x squared plus 6kx, and then we've got the y terms, which are y squared minus 2ky. Now we've got the number term, which is plus 7, and this is equal to 0. We are then going to look at the x terms and complete the square for that, and write this as x plus 3k squared minus 9k squared, and we're going to complete the square for the y terms as well, which will give us y minus k squared plus 7, and this is equal to 0. We can then simplify the like terms of minus 9k squared and minus k squared and rewrite this as x plus 3k squared plus y minus k squared, and minus 9k squared minus k squared gives us minus 10k squared, and we've got the plus 7. This is equal to 0. And now if we move the minus 10k squared and the 7 onto the right hand side, we have the equation of the circle, which is x plus 3k squared plus y minus k squared is equal to 10k squared minus 7. Therefore, for part 1, the coordinates of the center are going to be minus 3k and k, and for part 2, the radius is going to be the root of 10k squared minus 7. The question then says that the line with equation y is equal to 2x minus 1 intersects C at two distinct points. Find the range of possible values for k. So for part B, to find the points of intersection, we are going to substitute the line graph equation into the circle graph, which means that wherever we've got the y, we are now going to substitute it with the equation that represents y. So we're going to write this as x squared plus 6kx plus the y squared, which is now going to be 2x minus 1 squared. We've then got minus 2k multiplied by y. Again, we are going to put 2x minus 1 instead of y, and then we have the plus 7, and this is equal to 0. So we can expand the bracket and rewrite this as x squared plus 6kx plus 4x squared minus 4x plus 1 minus 4k plus 2k plus 7 is equal to 0. We can then collect the like terms, so x squared plus 4x squared would give us 5x squared. We then have terms which have both k and x, which are 6kx minus 4kx, and that would give us plus 2kx. We've then got the x term, which is just minus 4x. We've then got a term with just k, which would be plus 2k. And we've then got the number terms, which are plus 1 and plus 7, which gives plus 8. And this is equal to 0. So if we write this by grouping all the terms properly, we can write this as 5x squared, and the x terms can be written as bracket 2k minus 4x, and the number terms are 2k plus 8. Because the question is saying that the line intersects C at two distinct points, this means that the discriminant of this equation would have to be greater than 0. So b squared minus 4ac would have to be greater than 0. If we now substitute b is 2k minus 4, and we've got minus 4 multiplied by a, which is 5, and c is 2k plus 8. And this has to be greater than 0. If we expand the first bracket, we will have 4k squared minus 16k plus 16. 4 multiplied by 5 is 20. Therefore, 20 times 2k is 40k, and 20 times 8 gives us minus 160. If we collect the like terms, we can rewrite this as 4k squared minus 56k minus 144 is greater than 0. So if we look at this graph, we need to find the solutions, and we are looking at the sections which are greater than 0, meaning these two sections of the graph. So if we use the calculator to solve this equation, we can first go to menu and go to equation. We then select 2 for polynomial. We then select 2 again for degree 2. The a value is 4, the b value is minus 56, and the c value is minus 144. And that gives us the first x value of 7 plus root 85, and the second value is 7 minus root 85. So we can label those onto the graph. And therefore we can see that the possible range of values for k is less than 7 minus the root of 85, and k is greater than 7 plus the root of 85.